Hello, welcome to this video where I am going to prove the midpoint theorem, which states that if M is the midpoint of OA and N is the midpoint of AB, then 1. MN is parallel to OB, and 2. MN is equal to half of OB. So I have got a diagram here, the Cartesian plane, where this is the x-axis and this is the y-axis, meeting at the origin O, whose coordinates are 0, 0. I have assigned A coordinates x1, y1. And then I have assigned B x2, y2. But y2, because this is a point on the x-axis, the x value is 0 here. So the coordinates of B should be x2, 0. Now, the coordinates of M and N, I'm going to find them from the points OA and B. Bearing in mind that AM is equal to OM and AN is equal to NB, I can find the midpoint N using this formula, x1 plus x2 over 2, y1 plus y2 over 2. My x1 in this case, I'll call it this one, plus my x2, which is this one. So it's x1 plus x2 over 2. What about the y value? For the y value, I'm going to have y1 plus y2, which is y1 plus 0 over 2. This comes to y1 over 2. So these are the coordinates of N. Similarly, let us find the coordinates of M. x1 is this one. x2 is this one. But x1 plus 0 is just x1. So the coordinates of M will be x1 over 2, and the y value, let's also do the same. It will be y1 plus y2 over 2. But y2 being 0, it means I end up with y1 over 2 as the coordinates of M. So, and then we can join M to N to form a line MN. Okay, our job is to prove that, firstly, MN is parallel to OB. And then secondly, MN is half of OB. Now, let us first of all prove parallelism between MN and OB. How do we prove that? If lines share the same gradient, it implies that those lines are parallel. Let us use the formula for gradient, which is the gradient of a line M is y2 minus y1 over x2 minus x1. Now, let us do that for the gradient of OB first. So let's find the gradient of OB. Gradient of OB shall be this one, which is equal to, what is our y2? Our y2 is 0, minus our y1 is 0, divided by x2 is x2, minus x1 is 0. This gives us an answer of 0 since the numerator is 0, and 0 divided by anything, the answer is 0. Similarly, let us find the gradient of Mn. The gradient of Mn shall be dealt with using the same formula. y2 is going to be this y value here. Sorry, this one. The y value is this one. So it's going to be y1 over 2. Subtract y1 over 2 divided by the x values will be this one and this one. So this is x1 plus x2 over 2, subtract this one, which is x1 over 2. This is equal to 0 since the numerator is 0. No matter what this will be, this is 0 divided by any number, provided this is not 0. So this answer is 0. So I've got a gradient of 0 and a gradient of 0. These lines are sharing the same gradient. That is, the gradient of Mn equals the gradient of OB. That implies that Mn and OB are parallel. So the issue of parallelism has been proved. What is left now is to prove that OB is 2 times as much as Mn, or Mn is half of OB in terms of length. So we are going to apply the distance formula, but applying the distance formula in its full will be a bit cumbersome in the sense that if this line is horizontal, its distance, okay, I'm going to find the distance of OB. This is equal to the x value at B, subtract the x value at O. Because this line is horizontal. The y value won't matter because the y value is the same. So this is equal to, what is the x value at B? It's x2. Subtract the x value there is 0. So the value of OB in terms of length is x2. Now, let us check the distance of MN. Again, from the previous proof of parallelism that we have already established, we have seen that MN is parallel to this. So if this line is parallel to this being horizontal implies that this is also horizontal. So when I get the distance between M and N, I don't use the y values. I only use the x values. So it's Mn is equal to the x value at N, subtract the x value at M. Okay, this is equal to, the x value here is x1 plus x2 over 2. Subtract this one, x1 over 2. This is the same as, okay, you can split this one to x1 over 2 plus x2 over 2. You can split this fraction because they are sharing the same denominator. You can separate them like that. Minus x1 over 2. This is now equal to, we observe that this one and this one will go. So we remain with half of x2. Half of x2, this one. x2 over 2, which is just half of x2. So let's check now. Our Mn is half of x2. But OB is x2. We can see that these two are comparable in the sense that this one is actually half of OB, because OB is x2. This is half of x2. So Mn is half of OB. And that proves the second part of the theorem. This is the proof of the midpoint theorem using a method of coordinates. Thank you so much.